Alright, we're going to continue our discussion about conic sections. And so, in our previous lecture, we had mentioned that a specific conic section, the ellipse, has this shape. And one thing I wanted to clarify was the location of the foci. So if we look at an example in the real world, the sun is at the focus of this ellipse, and the earth, it orbits the sun in an elliptical manner. So if we wanted to look at the foci, when the ellipse is oriented this way, the foci lie along the horizontal axis, or the x-axis. And we have this equation here. If the ellipse is oriented like this, the foci lie along this axis. So in either case, the foci is always going to be on the major axis, whether the major axis is horizontal or vertical. Okay. So now let's work on a problem. In order to solve this problem, we're asked to find where the foci are in an ellipse. So we have an ellipse shaped like this. Again, pardon my poor drawing skills. We have two foci, one of which is here and the other one is here. So if we were to label the distance from the origin to the foci, we'll call it C. Okay? So again, the distance from either focus to the origin is C. Okay? We can relate the semi-major axis, which is this axis right here, that is A, and the semi-minor axis, which is B. We can relate these using the following equation. C squared equals A squared minus B squared. Now, if we had an ellipse that was vertical, and our foci were here, C is this distance right here. And your A is going to be this, and B is going to be that. Again, this is the semi-minor axis, semi-major axis. The same equation holds true for both. Okay, so find the foci of an ellipse. Find the foci of an ellipse with the following equation. Okay, the first step is to get it in standard form, and the second step is to use the following equation to find where the foci are. And we also want a graph. And just write that graph. Okay. So how do we write the equation in standard form? We know mistake right there. That should be 225. Okay. We know in standard form that the number on the right hand side has to be equal to 1. So how do we get a 1 here? We divide both sides by 225. So we're left with 1 on the right hand side. Now we'd have to simplify this fraction. This becomes x squared over 9 plus y squared over 25, and that equals 1. Now we are given this equation. We need to figure out what a and b are. So how do we figure out what a and b are? A is always greater than b, so we know this has to be a squared and this has to be b squared. So a squared lies along the y-axis and b squared lies along the x-axis. So c squared equals 25 minus 9. C squared equals 16, so C equals 4. And again, once you get the equation, it's a matter of seeing which number is bigger. The bigger number is always the major axis. So now knowing C, we can sketch the graph. And we know this one is going to be oriented vertically because the major axis lies along the y-axis. So our A squared is 25, so A is 5, and B squared equals 9, so B is 3. So we know it's vertical, it's oriented vertical, so we need to go up 5 units to the first vertex, and then down 5 units to the other vertex. The co-vertex is 3 units on either side. Remember again, the co-vertexes are the endpoints of the minor axis. So we can draw our graph. Lastly, we need to label the foci. So the foci are always along the major axis. So the major axis here is the y-axis. We go 4 units up and 4 units down. So if we were to write the points, the coordinates of the foci, these are the coordinates of the foci. Thanks for watching. Hope you learned something new.